Okay, here is part 2 of trig functions of any angle. So we talked about uh, in the last part how we were doing stuff, finding trig functions for angles within a right triangle, right? Right, we have a theta here, opposite, adjacent, hypotenuse, and so on. And then last section I talked about how for any angle, if we knew a point on its terminal side, an x and a y, then that was just like your adjacent and your opposite, and you could find the trig functions for that angle. Now, if you remember, on one of them I pointed out that our right triangle is actually right here, and that's the theta that we're putting for the opposite and the adjacent, right? The x value and the y value. But the angle that we're actually looking at or dealing with is right there. That guy inside there is actually theta prime, and that's what we're going to go over today so that you can see that they have the same values, the same trig functions. Okay, first we needed to review. You guys did this hopefully on that quick review quiz. We've got 30 degrees here. I want the sine of that. Well, that's 1 over the hypotenuse, 2. Cosine is going to be square root of 3 over 2. I'm just going off of my opposite, adjacent, hypotenuse. Okay, and then tangent is opposite over adjacent. That'll be 1 over square root of 3. But when you rationalize, it ends up with square root of 3 over 3. Okay, that was for 30 degrees. Now 45 degrees has a different triangle. These special right triangles, you're going to want to memorize them because we do everything we're going to do for the rest of the section revolves around those guys. So make sure you're familiar with them. This time we're looking at 45 degrees. Doesn't matter which one you do because they have the same thing opposite and the same thing adjacent. And then here's the hypotenuse. So sine is opposite over hypotenuse. Once we rationalize, that becomes square root of 2 over 2. Now, if you look at that, you recognize that the adjacent and opposite are the same. So cosine's also going to be square root of 2 over 2 because it will just be 1 over square root of 2 and it rationalizes. Okay, tangent. So katoa is what we're doing. Tangent is 1 divided by 1, so just 1. Okay, 60 degrees now, going back to this guy. Now our opposite, though, is square root of 3. Adjacent is 1. Same hypotenuse, though. So sine is this time is going to be square root of 3 over 2. Cosine is 1/2. And tangent is just square root of 3 over 1, which is actually just square root of 3. These values right here in this table, you're going to use again and again and again. You're going to see them over and over and over again. All right, here's how it works. Each of these angles has a reference angle of 60 degrees. Remember, reference angle is how far that angle is from the x-axis. So 60 degrees right here, he's his own reference angle, right? So his theta prime is 60. This guy right here, 120, he's about right there. That's 120. He is 60 degrees away. If you take 180 minus 120, you get 60. Review your reference angles if this is getting confusing. We just talked about them, so hopefully they're fresh. The next one is 240. He's down here in quadrant 3. Quadrant 3, you take 180 minus that angle, but it's the absolute value of it. So you would get 60 again. And then the last one is over here in quadrant 4. And in quadrant 4, remember, you take 360 minus 300 to get your reference angle. So all 4 of these angles have all 4 of them have a reference angle of 60. Sorry, I lost my train of thought. Now, if you refer back to that table we just made, the cosine of 60 is 1/2. if you were to plug this into a calculator, the cosine of 120 is negative 1/2. Cosine of 240 is negative 1/2. Cosine of 300 is 1/2. So when it comes to trig functions, if an angle has the same reference angle as another one, then they'll have the same value for the trig functions, except for what's the difference between these guys? It's just a plus or minus, right? Some are positive, some are negative. If I were to go in and do the sine of 60 is square root of 3 over 2. Sine of 120 is square root of 3 over 2. It's positive. Cosine, or sorry, already did cosine. Sine of 240 is negative square root of 3 over 2. And sine of 300 is negative square root of 3 over 2. So 2 of them are negative and 2 of them are positive. It just depends on which quadrant you're in that tells you whether it's positive or negative. So let's look at the quadrants. If I were to pull a point on the terminal side here, the x would be positive and the y would be positive, right? Now we talked about how we have x and y for points. That was part 1 of this. X squared plus y squared equals r squared. I told you r is always positive, always greater than 0. So if we're in this quadrant right here and I'm finding the sine, which is y, the opposite, over r, the hypotenuse. This is the stuff you just talked about. This is a positive number being divided by a positive number, which will give me a positive number. That is in quadrant 1. Now, if we move over here to quadrant 2, x is negative, y is positive. So the sine, which is y over r again, is going to be a positive divided by a positive. That'll still be positive. What about cosine, though? Cosine is x over r. That is a negative value because we're in quadrant 2 and that's moving left, which is negative on the x-axis, divided by a positive value, which gives you a negative. Now notice back here on this page, when we got to quadrant 2 right here, 120, this cosine answer was negative, but this guy was positive. So it all depends on what quadrant you're in. Let's look at quadrant 3. Quadrant 3 down here, both x and y are negative. So if I take the sine, which is y over r, that's a negative divided by a positive, the answer will be negative. Same with cosine, x over r, or adjacent over hypotenuse, negative over positive, negative. But if I take the tangent of this guy, that is the opposite over the adjacent, so y over x, that is going to be a negative number divided by a negative number, and now it's going to be positive. So in this first quadrant right here, quadrant 1, both sine and cosine are positive, along with tangent, because tangent is sine over cosine. Over here in this quadrant, sine is positive, cosine is negative, and then tangent, that's an identity, tangent is sine over cosine. If sine is positive and cosine is negative, then you're going to get a negative value. So tangent would be negative there. In quadrant 3, sine and cosine are negative, which means tangent is positive. This one, tangent was negative. This one, tangent's also positive. Okay, let's look at quadrant 4. This time the x is positive and the y is negative. So I bet you can guess what's going to happen here. The sine is going to be negative, cosine's going to be positive, and because they're different, tangent's going to end up being negative. So all of this right here, quadrants tell you what the positive or negative of each trig function is going to be. Just like in this right here. I knew by seeing that it was 120 and that it was in quadrant 2 that it was going to be a negative value. I knew that 300 was in quadrant 4, and I knew that cosine was positive in that quadrant, so I knew it was going to be a positive 1/2. And the 1/2 came from right here, this beginning one with the reference angle. Anyways, let's go through this step by step. When you look at trig functions and you're in a quadrant, in the first quadrant, all of them are positive. All of them are positive values. And then when you move to quadrant 2, only sine and his little buddy cosecant are positive. Cosine and tangent and their buddies are negative, always. Quadrant 2 angle, sine is the only guy and his buddy that gets to be positive. When you move to quadrant 3, tangent's in charge and his buddy, so they get to be positive. In quadrant 4, the only guy left is cosine and his buddy. They get to be positive. Everybody else is negative. Now, this mnemonic thing right here. A stands for all. S stands for sine. T stands for tangent. And C stands for cosine. That's who's positive in that angle. Or sorry, in that quadrant. So ASTC, that's all sad turtles cry. That's how I remember it. Some teachers say all students take calculus. But ASTC is how you're going to remember it. And you'll see me draw that on some of your work, the key and that kind of stuff, is I'll draw that up right there. Okay, let's practice some of this. All sad turtles cry. It says determine whether each of the following will be positive or negative. Cosine of 120. 120 is more than 90, but less than 180, so it's going to be in quadrant 2, which means it's going to be negative because only sine is positive in that quadrant. Okay, 225. Okay, got to look on my coordinate system here. Might help if I can actually draw one. I'm looking at it, I'm thinking of the angle 225. Here's 90, 180. It's not quite 270. It's in here somewhere. That's quadrant 3. And in quadrant 3, T is in charge, so he gets to be positive. Okay, next one is 3 pi over 4. It's radians, so we might want to switch it over to degrees to get a better idea of its actual value. Degrees are easier to deal with. That is 135, so that is about right there. That's in quadrant 2. And in quadrant 2, sine is positive. Okay, next one, 330. Okay, we're going along 90, 180, 270. About right there is 330. Looks like that's in quadrant 4. And in quadrant 4, C is in charge. He's positive. So the cosine is going to be positive. Okay, next one. 300 degrees. Let's see, we're going along here. We're at 90, 180. It's past 270. It's about right there. So we're in quadrant 4. Now in quadrant 4, cosine and his buddy are positive. Everybody else is negative. This is cosecant. He's in everybody else, so he's going to be negative. Okay. Next one. I think this is a dashed line, but who cares? Oh, 60 degrees. That's just right here. Oh, that's a cool pen. 60 degrees. That's in quadrant 1. And everybody is positive in quadrant 1. It doesn't matter if you are a buddy, if you're a sine, cosine, everybody is positive in that quadrant. Okay, all sad turtles cry. ASTC, that's going to be one of your steps.